Hi, Thomas Willingham here with Christopher Chapman, and we are here for course 98366 MTA Networking Fundamentals, and we are here to talk about TCP/IP tools.
We are indeed. There are a couple of them that we're going to go over today. So we should spend a couple minutes on 1 or 2 dozen tools that we have for TCP/IP networking.
Might even demo a few, show people how things work. And
We'll see how I feel.
Okay.
I'm thinking about it. We'll cross that bridge when we get to it.
Okay, let me use the command finger to advance the slides. There we go. So skills concepts that we're going to talk about using basic TCP/IP commands and working with advanced TCP/IP commands. So basically we've talked about TCP/IP and how it is a protocol used for internet communication. As you set up TCP/IP, it's helpful to have tools to verify connectivity, to troubleshoot connectivity, to verify routes, which we can talk about. And these are some of the tools that we're going to talk about: the command prompt, ipconfig, ping, and traceroute. So the command prompt is Microsoft's version of a command line interface. You can use the command line as an administrator, also known as running in elevated mode. And then these tools are referred to as command line tools as opposed to window-based tools or GUI-based tools because you run these in the command line. There are other sites that may have Windows-based versions of these tools, but the tools we're going to talk about are command prompt-based. ipconfig. ipconfig allows you to view the current configuration of the IP stack on your network device using TCP/IP. This command line utility has switches, one of which is /all, and this switch can be used to view additional details about each adapter. You can view information such as DHCP information, DNS, your IP address, your subnet mask. You can also use the ipconfig utility to refresh your DHCP and DNS settings. Ping. Ping is a very low-level way or method of verifying connectivity. So you verify connectivity with a ICMP echo request message. And if we look at the demo here, or we look at the graphic here, thanks to Christopher for these amazing graphics.
That's what I do. That's what I do.
So basically you have the first device saying, hey, are you awake? The second one, yes, I am. And basically that's all there is to ping. Ping is actually stands for Packet Internet Groper. It actually means something. It can be used to test IPv4 and IPv6 connectivity. Traceroute. Traceroute allows the ability to determine a path taken to a destination by sending an ICMP echo request message to the destination and then incrementally increasing time to live field values. Time to live is basically hops in the packet. So used to trace a network path, and it's useful if the local device is testing okay, but you're not sure the route is correct. So basically the network device, the client says, hey, how do I get there? Sends a message. And then you see as you hit each device, it forwards it to the next device. And you basically get a path from your source to your destination. Mm-hmm. So Christopher, why don't you show us how these command line utilities actually look and how they work?
I suppose I can do that. So we're going to jump into my already existing demo environment. I've got it up and ready to go. I'm sitting at what you'd see when you get to a typical server desktop. You're going to have Server Manager open. It opens by default. I have added command prompt to the taskbar via the Start menu. So I'm going to close Server Manager. I've also added it to my Start menu. So if I go to Start, it's... I guess I have to be on the right computer first. It's also right here.
Okay, so really quick, you had multiple start menus there?
I'm remoted in, so I've
Okay.
got my main desktop and then the computer I'm remoted into.
Okay.
So apologize for that.
So just to clarify, you
Yes.
are using remote desktop.
I am.
Okay.
So I have the command prompt. You won't find this here by default on a server. You've got to add it via the all apps option, or this will actually change a little bit in the next version, so you'll have to navigate through the next screens to get to it. The reason I put this here and on the task menu, I did want to demonstrate right-clicking and run as administrator. Were you to want to do that? Now I'm logged into this server as an administrator, so it's going to do that all by itself. You can tell at the top when I click it says administrator command prompt.
So on a so you mentioned you're logged on as administrator. For day-to-day working purposes as an administrator, is it a good procedure or is it a good process to be logged in on your server as an administrator?
Typically, well, it depends on what you're doing. Typically, you're going to be managing servers from a desktop that you're going to be logged into, not as an administrator. You're going to use run as, you're going to use different consoles logged in as different users. You're not going to be just sitting at a computer logged in as an administrator, typically. If you're remoting into a server, depending on that server and what its role is, you might, because you may have to. If you're troubleshooting a domain controller, you're going to have to log in locally as an administrator, unless you've changed permissions on those domain controllers to allow non-admins to log onto the desktop, which may or may not be a great idea. So it depends.
Okay.
So here we are. We're going to start right away. I'm going to use this to ping some internal addresses first. I've got some pretty generic names on this network, so I can do that. And the IP addresses are all internal, so it makes no difference.
And then notice the server name is resolved to an IP address,
Mm-hmm.
and then you get a reply from that IP address.
Yep.
And then we talked about before in the IP, when we talked about TCP/IP, kind of let's let people think about this, but what service or what protocol allows that name to be coordinated with that IP address? So let them think about that for a minute.
Yeah, does anybody remember?
Well, I hope they do. I hope they're hanging on every word, or
They
at least
should be.
every
They
other
should be.
word.
It's only been like 5 minutes since we talked about this, so.
Okay, so DNS.
DNS
is the domain name service.
Yep.
And that allows IP addresses to be converted to server names.
Yep.
Typically, we interface with server names. It's easier for us as people. We remember server names, and we do that over the internet, www.microsoft.com. We remember that. The DNS server is the system that uses or transfers that name to that address.
Yep. Gives us a name to remember, gives the computers the numbers it needs to actually function. So our next one, we're going to ping something external, see if we get the same result. Now in this case, you'll notice something weird happens. It says pinging, it resolves to an IP address, but nothing happens. I keep getting requests timed out. The reason that's happening, in this case, the endpoint, Outlook.com, they've configured their network devices to not respond to ICMP requests. So I can send my ping packet that says, "Are you here?" Their router's just completely ignoring anything going on.
But notice we still have DNS name resolution.
Yes, and we do get the IP address, so we at least know DNS is working. Now, this could also mean that the host is just down. This could mean a number of things, but in this case, I'm assuming Outlook.com is not down at 10 o'clock or 9 o'clock on any morning of the week, so hopefully. So it's the same idea. You can ping any address. You can ping by name. You can ping by IP if you want. You'll also get results. The other thing you can do, we talked about this briefly in a previous module, you can ping the same name with different protocols. So I don't want to look IP4, I want to see IP6. So, oh, that's not the way it's supposed to come up.
Oh.
I'm trying to think of an external address that would actually work. I can't think of any off the top of my head, but you can with that switch, despite the fact it didn't work here, and that's not going to work because it's an IP4 address. Despite the fact that this isn't working on my demo because I don't have IP6 configured correctly on the test network, with that -6 switch, you're going to ping IP6 and you'll be able to see those results. The next one, I'm going to throw a little fun one in here, CLS, clear screen, for anybody who doesn't know that. We talked about ipconfig. I'm kind of going a little out of order, but should be okay. This is going to give me information about the host I'm sitting on, in this case, the server I'm sitting on. Now, you do see an IP6 address on the screen. So this one does have IP6. It is working. But what wasn't working in that last one was that it can't resolve. I pinged by name IP6. It couldn't resolve the name to an IP6 address. So even though it has an address, it couldn't be found. ipconfig with the switch we talked about gives you much more detailed information. It lets you know what kind of adapter in this case I'm running Hyper-V. So my main network adapter is actually a virtual adapter. It's not a physical hardware network card. IP6, IP4. This adds DHCP information. If it's being used, in this case, this is a server, so it's not. I've got a static IP. NetBIOS over TCP/IP enabled if you're using it. Just more information, much more information.
That physical address, which is the MAC address we talked about previously.
We did, so that's right here. Now that's, well, we won't go too far into that topic. I was going to say this is virtualized, so that's a different conversation. And you will notice you can actually see, I did ipconfig all. There's the Hyper-V network adapter, and that's it. There's no, it appears as though there's no physical network adapter in this computer, in this server, and that's because I only have one network adapter, and I've allowed Hyper-V to take over and use it. So let's clear screen again. We'll do one more. We'll try traceroute. And in this case, I do want to use a public address that I know works. And this is that graphic I had where I'm saying to something on the internet, are you here? How do I get where you are? And then the devices between the client in this case, which is a server, and the server I'm going to are going to respond each one at a time and let me know where it's going. And some of this is kind of telling. You can actually trace your packets, Bellevue, Burien, Seattle, Seattle. I've done pings in classes where I'll be sitting in class in Seattle, ping a server at my house in Seattle, and the packets go through Virginia, Florida, UK in rare instances. In this case, we're going to San Jose. So this server probably lives somewhere in the Bay Area. Try one more just for fun. That's what happens when you traceroute something that's sitting right next to the server you're using.
Oh, also, can you ping, we talked about localhost?
Yes, we did.
127.0.0.1. Let's ping localhost and see what happens.
And I'm going to do this with the name first, so you'll notice I can use localhost. It doesn't resolve to 127.0.0.1 by default. Because this is server 2012, IP6 is the protocol it's going to try first. And the local host IP6 address is ::1. I can still ping 127.0.0.1, absolutely. And that works like a champ.
Great.
Hopefully, because this demo would be drastically impacted if pinging localhost was not working. So I think that's it for the first round of tools.
It is. Now we have our advanced tools. So we've talked about some basic connectivity tools. And again, the idea behind this is opening the command line. You've set up a system. Maybe TCP/IP isn't working quite correctly, or it has weird issues. So you can use these tools to troubleshoot your connectivity. So let's look at some of our advanced tools. Some of our advanced tools include netstat, nbtstat, pathping, nslookup, netshell, route with the -print option, net, and telnet. So netstat. This displays active TCP connections, ports on which the computer is listening, Ethernet statistics, the routing table, statistics for IPv4 and IPv6. Used without parameters, netstat displays active TCP connections. So active TCP connections, this is connections to other systems, whatever those other systems may be. Maybe you're browsing the web, so www.microsoft.com. Maybe you have a telnet session going. Maybe you're doing a remote desktop session. These would all be remote. Oh, maybe you're using file and print services. Maybe you're using a printer. Those would all be active TCP connections. NBTstat. This displays NetBIOS over TCP/IP, NetBT, protocol statistics for local and remote computers. NetBIOS. NetBIOS is kind of an interesting thing. It was developed in the 80s to allow applications to communicate over a network using the session layer of the OSI model. Okay, that's kind of interesting. What does that mean? Basically, NetBIOS allowed computers to have names similar to DNS, but before Microsoft really implemented DNS. This is when Microsoft used NetBEUI as one of their default protocols. NetBIOS was the naming scheme that was used. And NetBIOS tended to only work on local computers. NBT Stat displayed this NetBIOS information. PathPing, a command line routing tool that combines features of basically ping and traceroute, including some additional information. Sends packets to each router on the way to the final destination, and then computes results based on the packets returned from each hop. And each hop, a hop is basically crossing a router or a router device. PathPing can also show the degree of packet loss at any specified router, so this can give you a little bit of troubleshooting information. NSLOOKUP. NSLOOKUP can be used to diagnose domain name system issues, and it allows you to look up the name of a host to see if you're getting proper DNS name resolution. You should probably have a bit of familiarity with DNS before you use this tool. NetShell. NetShell isn't so much a command as it is a scripting utility. And what I mean by scripting utility is NetShell and then an option or a command allows you to perform different options. Commands work on local or remote computers. It provides us scripting features that allow you to basically run a group or a batch of commands against a specified computer, again, either local or remote. And you have the ability to save the configuration script in a text file in case you want to have like a little testing script that you're running on systems. You can save it, pull it down, and run it on the system. Route. Okay, so you have your local IP routing table. Your IP routing table defines what goes where. How do I get to, so if I'm thinking about going somewhere, I'm at Bellevue, Washington, and I want to get to Seattle, how can I get there? Well, an IP routing table can give you the paths to get there. I could take 520, I could take I-90, I could take 405 to the top of to the top of the lake. I could take 405 to the bottom of the lake. So these are all freeways that I could use to get to my destination. The IP routing table has similar functionality. The route print command can be used to display the routing table and is very similar to netstat-r. The route command can also be used to add and delete static routes, and we'll talk about the difference between static and dynamic routes later. It's very exciting. You should stay tuned. Net. Many commands use the net command that begin with the word net. It's not specifically part of the TCP/IP stack, but can be used to test network connectivity on your system. Telnet. Telnet isn't so much a troubleshooting command as it allows you to communicate with a remote computer using the Telnet protocol. You can initiate a Telnet session by saying Telnet and then the host name or IP address, at which point you get a Telnet prompt. This is a low-level prompt that you can perform basic commands at. Again, the network administrator can connect using Telnet IP address or Telnet host name. You can also test to see if different ports are working by saying Telnet server and then a specific port name. Back in the day, really good times were you would Telnet to the email port of a server, initiate a connection, and you could have an email directly from Santa. True story. Christopher, why don't you show how some of these utilities can work for us?
I can do that. I'm actually installing the Telnet client right now, so we'll have to wait on that last one for just a minute. But it'll be installed by the time we get back to here. So I made a list. I had to keep track of which tools we're looking at. So we'll start right at the top. netstat. This one's pretty straightforward. This is what it shows you. It shows you those TCP connections. In this case, Windows 8, like I mentioned, I'm remoted. So it tells me that this server is being remoted into by another computer. Microsoft DS, directory services, so my Active Directory, in this case, domain controller, also staying in sync with this machine. The rest of these are, I couldn't tell you, just looking at them. They're all ports that, probably dynamic ports generated by some other service.
Well, and let's go over that, Christopher. You said that you weren't familiar with all of these ports and IP addresses. There used to be a class, the Service and Support class, that talked about access to tools and access to basically resources. The idea as a good network administrator isn't to know everything. Technologies constantly evolve, they constantly change, they're constantly different. Things are tweaked. What worked one day may or may not work the next day just because the system's evolved and a little bit different. So the idea isn't to know everything. And if you're like, holy crap, I'm never going to learn any of this. There's just way too much. I'm drinking from a fire hose. Well, one, yes, you are drinking from a fire hose. Two, there is a lot to learn. But three, you don't have to learn everything. That's not the point. A really good administrator knows where to go and knows how to access resources. They know what the good sites are, and you'll start to find this out because different systems, you'll have different protocols, different hardware, different software involved. So you'll find sites that you need to use that will help you search this stuff out. So if you're looking at this stuff and go, wow, I'm never going to remember all those addresses, I'm never going to remember all that stuff, don't worry about it. You don't need to. That's not the point. The point is, if you look at that and go, I don't know what that is, but I remember it being about, I found that using the netstat command. I know this is an IP address, and from the : : 1, I know this is an IPv6 address. So you can pick up basic information, and then using that basic information, you can go and research more.
Well, on this particular screen, that's even more true in that the local address, : : 1. I know it's IP6. I also know that it is the loopback address. It's the IP6 version of 127.0.0.1. So these connections are self-contained connections. It's this server, some service on this server talking to either another service on this server or itself in some instances. So that is netstat, pretty simple. Our next one, as long as I can figure out how to type, NBTstat. Now this one, unfortunately, we're not going to get a whole lot of information because I don't run NetBIOS, I don't have NetBIOS clients, I don't have Win servers, but we can at least see how it works. This is one of the few tools that if you just run it by itself, just NBTstat, it's going to ask you for more information. It doesn't have a default state. So I need to tell it to do something with a switch. And it lists all the switches here. A very important note about this tool, this is one of not very many tools that is included in any Microsoft product that is case sensitive. You'll notice the switches, there's an A and a capital A. There's an S and a capital S. Those switches mean different things. In this case, we're going to do N. It's just a list of local NetBIOS names. The only names on here are the name of the server I'm on and the domain I'm on. So not a whole lot to NBTstat. These days, you probably won't use a lot of NBTstat or see a lot of information within it because it's not widely used. What's my next one? PathPing. So PathPing is going to look like a combination of two tools we've already seen. It's similar to ping in that it's going to get us some information about resolution, but it's like traceroute in that it's going to give us this route, exactly like it did in traceroute. Now at the end of this is where it's actually interesting. We get through this all the way down to the bottom. It doesn't take that long. Two more, ta-da. And now it says computing statistics for 300 seconds. It's actually going to track basically response times through this path from where I'm at to the endpoint that I'm trying to get to, and it's going to give me a report when it's done. It's an interesting tool. It's not one I've used a whole lot. When I'm troubleshooting network issues, it's usually just a matter of is something working or is it not, and why. So I'm going to go ahead and stop this. We're not going to wait the 300 seconds unless everybody wants to sit in silence for 5 minutes and wait, which we can do. Our next one, I like that I have to jump back and forth to keep track of all the tools. NSLOOKUP. This tool has saved, well, clients and dollars and networks and jobs in some cases a lot in my life. NSLOOKUP is a great tool for getting lots of information. And I'm going to do a couple of demos. I could actually spend probably an hour on this tool. I'm going to try not to do that. So for now, NSLOOKUP gives me a couple of pieces of information right away. Default server and address. It's going to grab the default DNS server IP from the server I'm on or the computer I'm on, and it's going to use that as the address. Now what you might see where it says default server is you might see a name unknown or unable to resolve issue if you don't have your reverse DNS entry set up correctly. We haven't talked about that a whole lot. I'm not going to go into detail, but reverse DNS is a requirement on an internal network for this to resolve to the name. It won't necessarily impact functionality as long as the IP address is correct. So we've got our server up, we've got an address. Let's get started. This one, you just type in what you're looking for, and it responds with an address.
And then notice, like Telnet, this brings us to a command prompt environment.
Yes, we have options, and that's what I'm going to demonstrate in just a moment. So we start with just very simple. I'm looking for a host. Give me host information, and it gives me that information. Gives me that information. It's a good little tool. But it allows me, this is a DNS troubleshooting tool. It's not just a name resolution, just pure names to IPs. I can do other things. Let's say I want to find out the mail server for a domain. There you go. This is actually going to give me the mail exchanger addresses for the domain I put in. I set the type to mail exchanger, I give it a domain, it gives me all the answers. Now it says non-authoritative is a little bonus information. It says non-authoritative answer because my server, this 10.0.0.10, does not have this information. It has to go out and get this information from somewhere else and bring it back.
And just real quick, so people understand, when you say type equals MX, you're telling DNS that, hey, I want to use a mail exchange. I want to get mail exchange information.
Yeah, it's a record type in DNS. We didn't really go into too much detail. I can do the same thing with aliases. And I'm trying to think of one I've actually got set up that would work. No, I don't have an alias for SharePoint on my internal network. I actually set up an A record. So to go back to the default, again, little bonus information, the default record type when you launch NSLOOKUP is A records. These are default DNS name resolution records. So now, this is going to be a little confusing because A records are typically associated to hosts, to endpoints. C names are aliases that assign a name to another host, which is what I should use for this SharePoint resolution, but I'm actually cheating a little bit and using SharePoint as an A record that I've created to point to my web server. I've used this, most of the time I use this to test when I'm doing public domain work. If I've set up a new domain, I'm hosting a domain, someone else has a domain they're trying to test, they're moving from one host to another, they're hosting mail in one place and web in another, you can use NSLOOKUP to make sure that all those records are being resolved correctly to the right endpoints. Oh, no, not CLI. That's not going to work. Exit and clear screen again. So NSLOOKUP, great tool. Like I said, we could spend an hour on it. It's tough for me not to. NetSH. Ta-da! There it is.
We're back to a prompt.
We are. Now, the problem with NetSH or NetShell, it's just that it's a shell. We're basically in a little operating environment for doing multiple things against local and remote servers. This one is it's even worse than NSLOOKUP in terms of we could sit here for an hour and look through NetShell. We could sit here for a day on NetShell if we wanted to. So this is just a demonstration of what this is going to look like. As Thomas mentioned earlier, one of the important things to know, and I thought about something while you mentioned that I'll talk about in just a second. Sitting in a NetShell prompt, it doesn't give you anything. If you don't know NetShell, you haven't used NetShell, you're new to NetShell, or even if you have used it but you want to do something new, how do you have any idea where to go? Question mark. There's your simple starting point. And the reason I go over this, the reason this rings in my head right now, is just last week, I'm going to exit NetShell, and just last week, I was watching a jumpstart, one of our jumpstarts, by two of our good PowerShell associates, Jeffrey Snover and Jason Helmick. And one of the things they said right at the beginning is, don't memorize this. which is an IT pro, it hurts a little bit. You're used to memorizing port numbers and names and servers and buttons and checkboxes and interfaces and screens and wizards and how to do as much as you can so you don't necessarily have to look things up. You want to be fast and efficient. PowerShell's gigantic. NetShell, not as gigantic, but it's the same idea. It's a shell that you may not use all the time. You don't have to memorize it. It's got the tools built into it to look up the things you need to look up on the fly. So there's your list of what you can do. You can do set, you can do trace. All these are different contexts, and that's why this is complicated. If I go into the HTTP context, let's do that. I have a whole new list of commands.
So the commands are context sensitive.
They are.
Depending on what context you're actually in.
Absolutely, and I have new ones. So see, I've got advanced firewall, I've got firewall, I've got IPsec. Now we go into firewall. And I'm not even setting things yet. I'm just using this to go into different interfaces. And right here, I do like this. In future versions of Windows, Microsoft might remove this functionality. PowerShell is the new standard, but we're still showing you the tools that do exist. So I could go 4, 5, 6 layers deep and then start setting options using the set command. I'm not going to go that much into it. Next one, route. This is one that you just type it up. It's going to give you additional information. It needs something from you as a user or as an administrator to do something. And it gives you all of your options, manipulates network routing tables. I don't like this description because it doesn't manipulate by default. If I do route print or route P, it's not manipulating, it's just showing me what they are. We are going to talk more about routing in, I believe, the next module. We have talked a little bit about it in the past. This is a network route table. This is something, in this case, that we don't manage by hand, although we can. And all this is a way to tell this computer what networks it's connected to and how to get to other networks that it may be connected to. You can do route add, route remove. I mean, there's a whole list of route commands if you want to do route tables by hand. It's very similar to, we talked about earlier, building Cat5 cables. Get the little wires and little crimpers and put the little ends on them. Fun the first time, never want to do it again. You know, route tables are not built for managing by hand.
Well, and initially we used to have, for DNS, before DNS really took off, we had host files. For NetBIOS, we had LM host files. So all these entries had to be made manually. And you're thinking, oh, well, that seems pretty overwhelming. Well, initially, there wasn't all the devices that are on the internet today. There were a lot fewer devices. These devices were more within a school, within a lab. So it was much easier to, within the lab environment, to control a host file that you put on clients that allowed clients and servers to access the 20 plus hosts that were in the environment. The environments weren't that huge. As the environments became bigger, then they needed solutions for more dynamic arbitration of this information. That's where things like WINS, DHCP, that's where those kind of tools and utilities kind of cropped up to overcome these static manual entry systems.
And we'll learn, in a routing context, we'll learn more about that in, I believe, again, the next module, how we've applied those same principles to routing to be able to connect multiple networks and not have to manage necessarily which networks are connected to which in terms of updating route tables manually for all of the devices on them. Our last two, we've got net. This is another one that requires additional information. I just type net. It doesn't do anything for me. I need to look at something, manage something, create something. Net use is a common one for anybody who's doing scripting or has done scripting, especially startup scripts via group policy. You can use net use to map network drives. Net use, let me see, what do I have available? I don't even know what I have. Server shared. Done.
Okay, now when you say map a network drive, let's just ensure that we're all on the same page here. What do you mean by map a network drive? I see you have M:, there. What did you just do?
So what I just did, I'll go to my start screen and open up my computer. I have created an additional, what appears to be an additional drive, M. And this is a drive that's connected, you can tell by the icon here, and the fact that it says network location. This is connected to a share on another server.
So now you have access to a remote resource as if it were local.
Yep.
So
as if it were a drive.
using a local drive, M, you now have access to a remote device. And again, this is seamless to the user.
Yep. And it's the same effect as right-clicking on computer and mapping network drive. Same idea. This just isn't scriptable. It's an interface. I have to go through and click buttons and next and finish. Whereas this, I can script. I can create a script that says just in it, netuse m, server vert, shared. I can put that script on a server, put it into group policy, and it's going to run on every computer in my enterprise every time it starts up or someone logs in.
So you could map a user directory, shared folders.
Yep. There are worse and better ways to do that. I mean, there are 100 different ways to do it these days. This is just an example of net, not necessarily an example of how you would map network drives for every user in an enterprise. At this point, this was the way at one point, but now there are much more and better.
Login scripts. There used to be login scripts where you would have to create a script that when a user logged on, it would run a batch file type of environment that would set the environment. You would map drives, you might set temp values, you might set system settings using this login script as user, and then you might have it set by group. So accounting got this environment, management got this environment, production got this environment.
Now we're into group policy, and that is a pit we do not want to get mired in today. But look for more classes. There will be plenty of courses that cover group policy as well in great detail. Our last one, Telnet, which I just installed. This is another one that it's just a prompt. So it seems like we have three options. We have a tool that you type it in, you hit enter, it says, I need more information, here are your options. We have a tool that you type it in, hit enter, and it actually does something. And then you have the scary ones, which are you type it in, you hit enter, and it just brings you to something with no information.
Well, I don't know. It doesn't seem that scary. It said welcome to Microsoft Telnet client.
It does say welcome.
It does everything but wave at you and give you a hug. What more do you need here?
That may be it. I mean, if that's all I need, I can just start this up and just stare at my desktop, feeling good about
feeling good about
the command line.
Yep.
Microsoft Telnet. So this is a way to connect to other servers via specific interfaces. I'm going to exit this out and come back into it the way I usually do. Sorry, it's quit, not exit. Telnet. Now what I'm doing is I'm connecting to a server that in this case is an email server that I know via a different protocol, SMTP 25. I'm now talking to my mail server via Telnet.
Could you create an email from Santa?
I could do that. I won't go through that right now. We don't have the time to go into that much detail. But I could right here in 2, 3, 4, 5 commands email myself from Santa or email someone else from Santa as long as their server accepted that it was from Santa and didn't reject it based on that information. So yeah, Telnet is a nice tool. Same idea. It's a lot of information. It's a lot of different things you can do with it, interfacing with other types of servers, troubleshooting different problems. Same idea. And exit. And that's it for the advanced command line tools, I do believe.
It is, actually. Sadly, we're at the summary already.
Are we?
We are. I mean, we've kind of blown through some stuff here. We've talked about the basic TCP/IP utilities, ping, ipconfig. We've talked about some more advanced utilities, path ping, trace route, NSLOOKUP. And again, these are just utilities that allow you to verify or troubleshoot TCP/IP connectivity. Christopher, I'll hand this to you for the additional resources and next steps slide.
Oh, that's right. We've got the cool slide. So this is next steps for this course. Once you've watched these modules, you think to yourself, what am I going to do next? I feel like I've got a good start. I feel like I've got some good information. How do I apply it? What do I do next with it? One of the options is a book, Exam 98-366 MTA Networking Fundamentals. It's a Microsoft official academic curriculum course that you can use to further study the topics we're covering in this course. There are instructor-led courses, again, 4 of them in different variations. Some of them are packs that come at a discount. There is at the very bottom, Networking Fundamentals, MTA Exam 98-366. If you want to take what you've learned here into a classroom where you'll get instruction from an instructor similar to what we're doing, plus peers who may be doing this in an enterprise environment or in any environment, plus potentially hands-on. I like teaching network fundamentals courses because we get to break things, we get to make some network cables, we get to cut some things, make some routers not work. And then at the end of any of this, or even at the end of this course, if you want to give it a go, there's the exam and certification 98-366 Networking Fundamentals for your Microsoft Technology Associate exam or certification.
Now, you've talked generically about the exams, the certification. Why would I want to take an exam? Why would I want to get certified? What benefit do I receive as a networking professional or somebody who wants to get into the networking profession?
Well, then you can go to parties with other networking professionals and show off how awesome you are. Compare transcripts. You can actually print them out, take them out, show them to your friends.
Compelling.
They'll love it.
Compelling.
The biggest reason is it's proof of skills. Potential employers, even potentially existing current employers, can see that you're demonstrating adoption of new skills, application of skills, or the ability to apply those skills in potentially a future job.
Well, and one thing that I typically tell people is people are familiar with the CPA for accounting. Mm-hmm. It's like a CPA for accounting. You have this title, you've studied, you've passed a series of tests, you have a certification. The certifications that Microsoft have are similar, but for networking. So you now have a networking certification that basically just says, hey, I have a certain level of skill.
Or in servers, or in clients, or in Exchange, or in any one of 100 other things. We have a pretty extensive cert program. So I think that's it for this module.
It's the end slide already.
Awesome.
It's a little sad.
I say already. It's been almost an hour. I'm watching the...
I don't know. Like I said, we get to this end slide. I'm a little torn. I'm happy we've got through the information, but this is our time. We're done at this point with this module.
It just means they got to start the next one.
Okay.
Of course, it means we have to start the next one too.
That's true. That's true. So we're looking forward to seeing you at the next module, or possibly at a certification class, or taking a test.
Yeah.
Come see us.